Hey kiddos, here's the spiral review for spiral 8. First off, we're dealing with graphing and solving. This is the last time we're going to see this section, so this is a great time to really focus on this and get you to the best understanding that you can. First part, we've got to graph a couple things. We're going to graph probably one parabola, one absolute value. I might identify the first thing I notice is that this is a parabola. In other words, some kind of a u. I see a negative out front. I know it's going to be a negative u. And I also know the vertex is going to be at 1, 3. That's where I'm going to start this thing. So at 1, 3. And then negative 2 out front means I'm going down 2 on both sides. For a parabola, I can only go down 2 on one on each side. I can't keep going for that slope because the parabola is not a linear function. It's going to change as it goes down and keep getting steeper. So this should look like some kind of a U. It's a little bit tough to show this, but make sure that this is not some kind of a pointy thing. For the next one of these, and for that we're looking at C. This is an absolute value. That means it's going to be some kind of a V. Because of a negative, it's actually going to be an upside down V. The vertex would be at negative 2, 2. So that's going to be here. And down 5 would be my instruction for each side of this. So 2, 4, 5 on both sides. And my points here would be linear. This is an absolute value. It's a V. And it would look something like this. Nice and steep and really hard to draw. That's not too bad. Continuing on the section, you know you're going to have to solve an absolute value equation algebraically. So looking at that, that's going to be negative 3, the absolute value. 2x minus 11 minus 8 is equal to negative 14. I don't know why I just recopied that, but hey, you know. We know we're trying to get that part by itself. I might start out by adding 8 to both sides. And when I do that, I get negative 3 times the absolute value of 2x minus 11 is equal to negative 6. I might divide both sides by negative 3. And I get the absolute value of 2x minus 11 is equal to 2. At this point, we can make our two equations. We have a positive 1. 2x minus 11 is equal to 2. And we're going to have a negative version, which is going to be negative 2x minus 11 is equal to 2. Solving the positive one first, I'm going to add 11 to both sides. I get 13 divided by 2, and I get x is equal to 13 divided by 2. On the other side, we're going to have negative 2x plus 11 is equal to 2. Minus 11 to both sides, we get negative 2x is equal to negative 9, which means that x is equal to positive 9 divided by 2. All right, we're looking at a problem with Miss Glynn throwing calculators off of a roof. And all 4 of these are listed in the video just so we can make sure we talk about each of these things. The big idea here is I want you to think about a vertex or y-intercept or x-intercept for every single one of these problems. For question 4, how high off the ground was Miss Glynn when she threw the calculator? This is at the beginning. This is a y-intercept question. So in terms of how to do this, that means when t is equal to 0. So we've got negative 2, 0 minus 6 squared, and then plus 11. Oh, I think this is going to be fun. So that's going to be 36. 36 times negative 2 is negative 72. Plus 11 is going to be negative 61. And I think we're in meters, which totally doesn't make sense for this problem, but that's okay. This is what happens if I make a problem too quickly and don't pay attention to the numbers I'm using. When will the calculator be at its highest point? Highest point, as soon as I see that, I need to say that that's a vertex question. So if we had a graph, I'd be looking at the vertex, and if we don't, I need to think about the value here. So we're looking at the points that have to do with my vertex, t minus 6 and 11. So that's at 6 comma 11. And that means at 6 seconds, that's my time value, it's going to be at 11 meters. That would be the highest point on this graph. When will the calculator hit the ground? Okay, so that's a 0. So 0 is equal to -2 and t minus 6 squared plus 11. The minus 11 then divided by -2. And that's going to end up being 5.5 is equal to t minus 6 squared. Take the square root of both sides, and I get plus or minus the square root of 5.5 is equal to t minus 6. The -1 isn't necessarily going to make a lot of sense here. It would end up being a positive value, but that's just kind of where the graph's going up before it comes back down. So we're looking for moving 6 to the other side, 6 plus the square root of 5.5, whatever that value is. How high will the calculator be after 5 seconds? Okay, so that means I've got to plug in 5. So -2, 5 minus 6 squared plus 11, and I get 9 when I do that out. And after 10 seconds, I've got -2 and 5 minus 10 squared plus 11, that's -50, so positive 11 plus -50 is -39. This would be below ground, which also kind of is weird, but you know, we're starting below ground anyway, so there's a lot of stuff wrong with this problem. Woohoo! Next up, we've got factoring and solving. This is the first time we're going to see this is graded, and you definitely want to make sure that you have some understanding of what's going on here. In terms of number 8, this is one of the problems that is being gotten wrong more often than not for the last 2 spirals. So please make sure that you have an understanding of how to do this. It's going to be really similar to solving an absolute value function. And if we do this as 0 is equal to 4 times the quantity x minus 1 squared minus 100, then add 100 to both sides. So we got 100 is equal to 4x minus 1 squared. Then we divide both of those by 4. Those cancel. I got 25 is equal to x minus 1 squared. I'm going to take the square root of both sides. And from here, I'm going to have 2 answers. 5 is equal to x minus 1, which means x equals 6. And -5 is equal to x minus 1, which means x is equal to -4. Whenever I take my own square root, I need to incorporate both the positive and negative version of that. For number 10, this is just kind of really making sure that you have an idea that if you're trying to find the zeros and you're in factored form, that you know that both of these factors, both of these parentheses, could be 0. The 2 we can ignore because 2 does never equal 0, but x minus 3 equals 0 when x is equal to 3, and x plus 5 is equal to 0 when x is equal to -5. For number 11, we got to factor in order to make this happen. And in doing that, we're going to do a times c is going to be 24, and b is -11. So I'm trying to find things that multiply to 24 and add up to -11. That's going to be -8 and -3. No expectation that you should be able to do that in your head. I just want to make this a relatively fast video. So that would give us 2x squared minus 8x minus 3x plus 12. When we go into grouping, the first 2 I can take a 2x, and I'm left with an x and a -4. The second two I can take out a minus 3, and when I divide that, I get an x and a minus 4. My x minus 4s are in common, so we get x minus 4 with leftovers of 2x and minus 3. That means that x minus 4 is equal to 0, so x is equal to 4, or 2x minus 3 is equal to 0, which gives us x is equal to 3 over 2. For number 13, we've got to start by writing this in factored form. You do the same thing we just did, and do a times c, which is going to be 12. B is going to be negative 8. That's going to be negative 6 and negative 4. I can factor this by grouping, and the end result would end up being that n of x is equal to x minus 6 and x minus 4. Factored form done. Find the zeros. So 0 is equal to x minus 6. 0 is equal to x minus 4. We're dealing with x equals 6 and x equals 4. Find the vertex. We said that the vertex, that the x value was going to be exactly in between these two things. Exactly in between 6 and 4 is going to be 5. To get the y value, I'm going to plug that in. I like plugging it in here. And when I do that, we get 5 minus 6 times 5 minus 4, which comes out as negative 1. My vertex would be at 5, negative 1. The y-intercept, we like using the original because it just ends up being that last number. Because when you plug in 0 for x, the first two parts go away. So the y-int would be at 0, 12. And then sketching a graph of this, we've got 4, we've got 6, we've got 5, negative 1, and we've got 12. Some kind of a nice parabola-shaped object. We'll complete that. That leads us into quadratic formula and complex numbers. This is still a feedback section. First off, we've got to use the discriminant b squared minus 4ac. And based on what this value is, we had three different options: if it's greater than 0, if it's equal to 0, or if it's less than 0. And when we had these, the top one gave us 2 zeros. If it's equal to 0, we have 1 0. And if it's less than 0, we have none. It also does a nice part of the calculation for quadratic formula ahead of time, so we can use that to help us with the problem as well. Okay, for this problem, we've got a is equal to 3, b equals negative 1, and c equals 2. So for b squared minus 4ac, we're looking at negative 1 squared minus 4 times 3 times 2, which is positive 1 minus 24, negative 23. That's less than 0, so I'm going to assume that there will be no real zeros. Okay, when we do this out, we've got negative 1 over 2 times 3, plus or minus the square root, negative 23 over 2 times 3. I'd like you to write this as 1 over 6, plus or minus the square root of negative 23. We're going to rewrite as the square root of 23 times I. I'd like you to pull that I out, and that's also over 6. You do not have to go any further with this. For number 17, I think I'm only going to do one of these because they're basically the same problem with different numbers. I'm going to start off the same way. So part A is going to be the b squared minus 4ac thing, which in this case it's going to be negative 7 squared minus 4 times 5 times 3. That's 49. Minus 60 is going to be negative 11. We'd expect there to be no zeros because this is going to be imaginary. Quadratic formula, that's part B. So x equals negative 7 over 2 times 5 plus or minus square root of negative 11. We already calculated that over 2 times 5. Again, negative 7 would be 7 over 10 plus or minus. And let's pull an I out of this, so square root of 11, I, make it positive, and that's over 10. On to these complex number problems. Square root of negative 72. I'm going to try to identify the biggest thing that I can that multiplies to 72 as far as a perfect square, and I might notice that 2 times 72 would work for that. So I know that this has to be a negative 1. I notice this might be a 2, and that this could be a 36. That's going to be I times the square root of 2, and 36 is the square root of 6. That's leaving you with 6I square roots of 2, or some equivalent expression. I would also accept the square root of 72 times I as your final answer. That would be 100% credit for that. For number 22, we are adding. 2 plus 1 is 3. And then 6I plus negative 9I is minus 3I. Nothing else to combine. At this point, you are done. For number 23, 4I times 8 is going to be 32I. 4I times negative 9 is going to be minus 36I squared. I squared, we said, was the same thing as negative 1. That's going to be plus 36 and 32I. For number 25, got to do some double distribution. 4I times 4I is 16I squared. 4I times negative 3 is negative 12I. 3 times 4I is plus 12I. And then 3 times 3 is minus 9. You might notice that the two middle pieces end up canceling each other out. 16I squared, we said that that was I squared is negative 1, so it's negative 16. And then minus 9 is going to be minus 25. That's kind of cool. It comes out as a number. And onward to the new section. This is going to be completing the square and graphing circles. The goal here is to write this as some kind of a perfect square polynomial, and then use that to do vertex form in order to sketch this thing more easily. I'm going to find both perfect squares first, and then work from there. So I know this has to be y is equal to x squared plus 4x plus something. And to get that something, we do that middle term divide by 2, which is 2 squared is 4. I would love for this 1 to be a plus 4 instead. I'm going to add 3 to both sides. So y plus 3 is equal to x squared plus 4x plus 4. Okay, continuing with that, we're going to factor the right side, which factors into x plus 2 into x plus 2. This is using a times c factoring, but I'm not going to show the step out. X plus 2 times x plus 2 is x plus 2 squared. If I minus 3 to both sides, we get x plus 2 squared, and then minus 3. I'd like you to notice that the thing inside the parentheses also was the number that we divided by 2. So 4 divided by 2 gave us 2. That's the number that showed up in the middle. That's going to be consistent for all of these problems. For B, we're doing the same thing. I'm going to start off by figuring out what this should be. So x squared minus 8x plus something. Negative 8 divided by 2, and then squared, that's negative 4 squared is going to be 16. To make 12 into 16, it's going to be plus 4, plus 4. So y plus 4 is equal to x squared minus 8x, and then plus 16. So y plus 4, and we're going to factor this right side. It's going to be x minus 4 squared. Finally, I'm going to minus 4 to both sides. We get y is equal to x minus 4 squared, and then minus 4. Sketching the graphs for these. First one has a vertex of negative 2, negative 3, and a steepness of 1. Second one has a vertex at positive 4, negative 4, and a steepness of 1. For the next part, we're doing some equations of circles. You've got to identify the center and the radius and then sketch a graph. We know that the center is going to be based on the things in parentheses, just doing the opposites. And the radius is going to be based on the square root of that last number. So the center here would be 2, negative 3. And a radius, the square root of 9, is going to be 3. So at 2, negative 3, that would put us there. And a radius of 3 going 3 in each direction gives us something that looks like this. For the second one, we're looking at a center of negative 2, positive 3. Square root of 16 would be 4. So if we take a look, negative 2, 3, and going 4 in all directions gives us something that looks like this.